Yes class, today we discuss about chapter number 5.2 solutions, NCERT class 12th, continuity and differentiability. So exercise 5.2 question number 1. Question number 1 given that differentiate the functions with respect to x in exercise 1 to 8. So first of all we just discuss about the differentiation. What is meaning of a differentiation? Differentiation meaning the rate of change of any function with respect to given function. This is the part. So we can discuss by this part d upon by t of ax. This term shows that rate of change of a particular function with respect to a given function. So here a function is equal to sine of a x square plus 5 with respect to x. So in question number 1, we can write let y is equal to sine of bracket start x square plus ka 5. We just want to differentiate with respect to x this function. So what we write? We can write differentiate with respect to x both side. What we write? Both side. So we can do one thing, dy upon me dx. This d upon dx shows that rate of change of function y with respect to x. So same part, d upon dx bracket start sine as it is of x square plus 5 and bracket close. So we know that what is the rate of change of sine of x. So we can write because given differentiation of sine of x is equal to cos of ax. So we can write sine of ax replaced by the cos of ax. Then dy upon me dx is equal to replacement of a sine x is equal to cos as it is angle same x k plus ka 5. Now we can differentiate the angles of the sine of x. So what we write? We can write class d upon dx of angle. Angle mean x square plus of a 5. After that we can write dy upon me dx is equal to sine, this is the cos, this is the value of the cos. We can write cos of x square plus me 5. Now differentiate shows the distributive property. Differentiate with respect to x square, x of x square and 5. So d upon dx of x square plus d upon dx of 5. What is the meaning of x square? We can write cos as it is x square plus 5 into x square meaning of a 2 of ax and 5 becomes 0 plus 0. So we can write twice of ax cos of x square plus 5. This is the dy upon me dx. Question number 1. Okay class, now we discuss about the question number 2. So what we write? We can write these questions by this method. In question number 2, y is equal to cos of sine of x. We just want to differentiate y with respect to x. So we can write differentiate with respect to x. So what we write? dy upon me dx is equal to d upon dx, which functions cos of sine of ax. So this is the formula of a differentiation. Which one? Cos of ax. We can write minus of a sine of ax. So we can write dy upon me dx is equal to cos mean minus of a sine, minus of a sine, bracket start, sine of ax. Now we differentiate of the angle. So d upon dx, which one part? Sine of ax. So we can write dy upon में dx is equal to minus sine as it is of sine of ax into what is the differentiation of a sine of ax? We know that cos of ax. So we can write cos of ax and we give the region. Differentiation of sine of ax is equal to given the cos of ax. So we can write dy upon में dx is equal to minus sine of sine x into में cos of ax. This is the question number 2. Now we discuss about the question number 3. We just find differentiate sine into ax plus b with respect to x. So what we write? First of all, we can write let y is equal to sine of ax plus of b. Same part, we can write differentiate with respect to x both side. If we write only differentiate with respect to x, it means right. So dy upon में dx is equal to का sine differentiate as it is same sine of ax plus of a p. This one condition, and everybody know that, and we know that differentiation of a sine of ax. What is the meaning of that? Cos of ax. So we can write dy upon में dx differentiation of sine of a cos angle as it is ax plus का b. Now we can differentiate the angle also, d upon में dx, which one part? ax plus b, bracket close. So we can write dy upon में dx is equal to part cos as it is same, ax plus b as it is same. Now differentiation region that a of x meaning a as it is differentiation of ax, dx by dx is equal to 1. We get the value of a, and differentiation of a b, we can say that 0, because we know that constant part differentiation is equal to the 0. So what we write? We can write a plus of 0. So we can say that dy upon में dx is equal to a as it is cos of ax plus का b. This is the answer. Okay class, now we discuss the question number 4. In question number 4, given that let y is equal to secant of tangent, this one power the half tangent of root of ax, which is find the differentiation of this function. So we can write differentiate with respect to x. So what we write? dy upon में dx, same part d upon में dx, which one part? Secant of tangent bracket start root of ax. This one condition. So we know that differentiation of secant of ax, what we get? We get secant of x into tangent of x. So we can write simply, so dy upon में d of ax, dy upon में d of ax. So class, dy upon में d of ax is equal to का part secant mean secant of tangent root x into में tangent of tangent root of ax. Here tangent root x behaves as angle. Now we can differentiate the angle also. After solving this part, we can say the differentiation of tangent of root of ax, and we know that differentiation of tangent x is equal to secant square of ax. So what we write? We can write here dy upon में dx is equal to same part secant of tangent root x. into में tangent of tangent root x, and we know that differentiation of a tangent x is equal to secant square of root x. Now here secant square root x and root x behaves as angle, so we can differentiate angle also. So what we write? Differentiation of root x, and we know that differentiation of root x is equal to 1 by 2 root of x dx by dx is the particular power solutions of there. So we can write class these conditions. Then dy upon में dx is equal to same secant of tangent root x, same tangent of tangent root x, same this one secant square of a root x, and this one 1 by 2 root of a x dx by dx is equal to 1. This is the differentiation of the secant of tangent root of a x. Now question number 6, we can find the differentiation of this condition given. So first of all we can write y is equal to cos agt same x power 3 into sine square x power of a 5. Class, we know that uv method differentiation, this is the u and this is the v. U as it is differentiation of a v plus v as it is differentiation of a u. This is the differentiation part. We can see the product method. So we can write differentiate with respect to x. So dy upon में dx cos of x cube as it is differentiation same part sin square x power 5 plus में sin square x power 5 as it is same differentiation as it is cos of x power of a 3. Here the power of a 3 ना कि cos cube. So what we write? We can write dy upon में dx, dy upon में dx same part cos of x cube as it is same power, we can put down the power to sine power of a 1 x cube as it is differentiation of a sine cos of x cube and differentiation of a angle x cube plus का sine same part sine square of x power 5 differentiation of a cos, we can write minus sine of x cube and differentiation of a angle x power of a 3. So we can write dy upon में dx. The as it is same 2 as it is cos of x cube sine of x cube cos of x cube into d upon dx of a x cube 3 of x square plus का same part plus minus minus sine square of x5 as it is same sine of x cube minus 3 of x square. This is the dy upon में dx. We can find this method. Okay class, this is only questions. Same be up in keep study. Bye बच्चों.